Frames in machines are consisting of multiple parts assembled together in a number of possible ways. The primary difference between frames and machines is that there are moving parts in machines and not in frames. The method of analysis is the same. The solution to these systems typically requires the drawing of the free body diagram of individual parts and the application of the equilibria equations. Therefore, one must be careful in recognizing the existence of two force members, that would identify the direction of the unknown force. This animation actually shows the frame in reality, and we used to see it in the books, and this is how it is actually. So let's have a quick example to illustrate the idea of the frame and machine. So here we got this frame, and we want to figure out the unknowns in this frame. Okay, so first thing we need to do is to draw a free body diagram. It's very important to draw a free body diagram to make it simple. Okay, and put the reaction forces on it. And after that, we can take a moment about point A, because it's because we cannot take it in FE, because we got two unknowns here. So it's a very proper to take a moment about point A to get rid of those forces. Okay, and once we take a moment about point A, we can find the force Fe, and be careful, here we had a angle 20 degree, and the same way we can take the summation of forces in y direction and set them to 0, and we can find the force Ay, and it's minus, and instead of putting minus, you can just put an arrow moving downward to indicate that it's minus. The same way, the summation of forces in x direction, set them to 0, and find the force Ax, and it's 128.4 Newton to the left. Okay, and if you forget the arrow, you don't have to forget the minus. Okay, so now we need to break the frame down to find the other unknowns. We got Cx and Cx and Cy. Okay, so we take a moment about point C, so we can find the force FBD, and it's equal to 308.8 Newton to the right, and the summation of force in x direction will give us the Cx, and it's equal to 154.4 Newton to the left. And finally, the summation of forces in y direction, set them to 0, and so we can find the Cy, and it's actually equals to 424.3 Newton downward. Okay, that's all. Hope that helps. Thank you very much.